Chain rule. This section includes derivative of composite function using chain rule, derivative of function using general power rule, and derivative of trigonometric functions using chain rule. The chain rule. If y equals to f of u is differentiable function of u, and u equals to g of x is a differential function of x, then the composite function y equals to f of g of x is a differentiable function of x. And the derivative of f of g of x equal to derivative of the outer function f evaluated at g of x times the derivative of the inner function g of x. Mathematically, d over dx of f of g of x is f prime g of x times the g prime x. So example 1, find the derivative of the trigonometric function y equals to sine pi x squared. So let's see, y equals to sine pi x squared. Sine is the outer function, pi x squared is the inner function. We differentiate the outer function sine, but keep it pi x squared as it is. At the end, we multiply by the derivative of pi x squared. So we have this dy over dx equal to sine becomes cosine. Keep the pi x squared, multiply outside d over dx of pi x squared. Now pi x squared we can write as pi square x squared. So we have a cosine pi x whole square times d over dx pi square x squared. Now pi square is just a coefficient. So using the combination rule, this becomes pi squared times 2x. Now we can rewrite pi squared 2x in the front as 2 pi squared x times cosine pi x whole square. And that's the derivative of y equals to sine pi x squared. Example 2. So let's find the derivative of y equal to 3 times tangent 4x. So let's start with y equal to 3 times tangent 4x. So here tangent is the outer function, 4x the inner function. So we'll differentiate the tangent, write the 4x, and then at the end multiply with the derivative of the 4x. So we'll have y prime, 3 is 3, tangent becomes secant square. Just type copy 4x and then multiply d over dx of 4x. Now differentiate 4x, that becomes 4. So now we simplify, so 3 times 4 becomes 12 and secant squared 4x. The general power rule. On any rational number n and a differentiable function y equals to u of x to the power n, the first derivative is y prime n times u of x n minus 1 multiplied by the derivative of u of x. Example 3. Find the derivative of the function y equals to 2x minus 7 to the power 5. So let's start with y equals to 2x minus 7 to the power 5. The general power rule, d over dx, ux to the n is n times ux to the n minus 1, d over dx of ux. Now here ux is 2x minus 7. So we apply this power rule, so bring the power down 5 and just write 2x minus 7, which is our ux, and subtract 1 and then multiply d over dx of this one, which is u of x, 2x minus 7. So let's simplify, bring down 5. Now 2x minus 7, subtract 1 from 5, make it 4. Now here we differentiate 2x, becomes 2 times 1, and the derivative of 7 becomes 0. Now we simplify further, so this becomes 2, and this becomes 5, and 2x minus 7 to the 4. Now 5 and 2 we can multiply, so the final answer is 10 times 2x minus 7 to the power 4. So example 4, find the derivative of f of x equal to 3 times the cube root of 4 minus 5x squared. So let's start with f of x equal to 3 times the cube root of 4 minus 5x squared. So first we change radical to exponential form. So this becomes 3 times 4 minus 5x squared to the power 1/3. Now we apply the general power rule. D over dx of u to the n is n times u to the n minus 1 d over dx of u. So u is 4 minus 5x squared. So we write 3 and bring down 1/3, multiply with the 3, and then we write 4 minus 5x squared to the power 1/3, subtract 1. But now we find the derivative d over dx of this part, 4 minus 5x squared. So simplified, 3 and 1/3 becomes 1, and this becomes 4 minus 5x squared, and 1/3 minus 1 becomes negative 2/3. Now here we break it down into two derivatives. So we can d over dx of 4 minus d over dx of 5x squared. So we just, since a negative power, so we can use the negative exponential rule. So we write 1 over 4 minus 5x squared to the power 2/3. And the derivative of 4 is 0, and the derivative of 5x squared is 5 times 2x. Now we simplify, and this becomes negative 10x, and we rewrite 4 minus 5x squared 2/3 as 4 minus 5x squared and to the power 1/3. So 1/3 means cube root, so it becomes cube root of 4 minus 5x squared. So final answer is negative 10x over cube root of 4 minus 5x squared. So example 5, find the derivative of y equals 1 over x minus 2. So let's start with y equals 1 over x minus 2. We're going to use a chain rule. So in order to use a chain rule, we're going to rewrite this as x minus 2 to the negative 1. Now we apply the general power rule, which says just bring the power down, rewrite the ux, and subtract 1, and then multiply the derivative of the u, which is here x minus 2. So we simplify it to negative 1 to x minus 2 to the power negative 2, and the derivative of x we make a 1, derivative 2 is 0. Okay, so now we use the negative exponential rule, and we write negative 1 over x minus 2 squared. So let's find the derivative of function y equals to 1 over the square root of 3x plus 5. So let's start with y equals to 1 over 3x plus 5 square root. We change this into exponential form. So we'll write as 1 over 3x plus 5 to the 1/2. Now we move this to the top using this negative exponential. So we'll have 3x plus 5 to the negative 1/2. Now we apply the general power rule. And general power rule says you bring the power down, and then don't do anything within parentheses, just copy this u of x, but subtract 1 from the power, and but in the end multiply by the derivative of the 3x plus 5, and that's called chain rule. Now we simplify, so we copy negative 1/2, 3x plus 5, so minus 1/2 minus 1 becomes minus 3/2. So the derivative of 3x is 3 times 1, the derivative of 5 becomes 0. So we simplify this into 3. And see the negative power, so we can bring this down on the denominator. And so we'll have minus 3 over 2 times 3x plus 5 to the power 3/2. So we can change to radical form, so you find we have 3 over 2. The square root of, because the divisor is 2 here, of 3x plus 5 to the 3rd power. Example 7. So let's find the slope of the tangent line to the sine function at the origin. And we compare this value with the number of complete cycles in intervals from 0 to 2 pi. So let's write down y is equal to sine 3x. And now we use the chain rule d over dx of sine of u is cosine u over d over dx of u. Now here u is at 3x. So we can write y prime, we write the derivative sine as cosine, but just copy 3x. But at the end you multiply the derivative of 3x. And now we write down cosine 3x, now derivative of 3x is just 3. So now we just rewrite and become 3 times cosine 3x. Now at the origin the point is 0, 0, so we substitute x equal to 0. So you will have y prime equal to 3 times cosine 3 times 0, and 3 times 0 is 0, so you have a 3 times cosine 0. Now cosine 0 you can put on a calculator or can table, and that's 1. So this becomes 3 times 1, which is 3. The slope is then 3. Now the number of cycles in the top, so these are starting here, that's 1 cycle, and then 2 cycles, and then what? 3 cycles. So it looks like the slope is equal to the number of cycles. So let's do example 8. Find the slope of the graph of function f of x equals to 1 over x squared minus 3x to the power 2 at 4, 1 over 16. So let's write this function f of x equals to 1 over x squared minus 3x to the power 2. Now we rewrite using 1 over e to the n is e to the minus n. So this becomes x squared minus 3x to the power negative 2. So now we apply the generalized power rule, which says d over dx of u of x to the n is n times u of x n minus 1 times d over dx of ux. So we apply this one, this is, so we bring the power down negative 2, write down x squared minus 3x and subtract 1 from 2, it becomes negative 3. But then we multiply d over dx of x squared minus 3x. So we now just copy down. It's minus 2 times x squared minus 3x to the power negative 3, and here we write the derivative of x squared, which is 2x, and the derivative of 3x is 3. Now we rewrite this using the negative exponential rule. So now we have first derivative of fx equal to minus 2 times 2x minus 3 over x squared minus 3x to the power 10. So now we use the point 4, 1, 16 and substitute x equal to 4 with the axis. So f prime x becomes f prime 4 and we minus 2, 2 times 4 minus 3, 4 squared minus 3 times 4. Now we're simplifying, so we got minus 2 times 4 times 2 is 8 minus 3, and 4 squared is 16, 3 times 4 is 12. So further simplifying becomes negative 2 times 5 over 4 cubed. So 2 times 5 is 10, 4 cubed is 64. We can reduce it to minus 5 over 32, and that is the slope. So example 9, find the equation of the tangent line to the graph of the function at the given point. So here f of x is sine 8x and the point is pi comma 0. So let's start with f of x equals to sine 8x. We differentiate using chain rule. So the outer function is sine, make a cosine, copy 8x, but then multiply with the derivative of 8x. So then rewrite cosine 8x, the derivative of 8x is 8, put 8 in the front. So the first derivative of f of x is 8 times cosine 8x. So now we have first derivative 8 cosine 8x. So now we'll substitute x equals to pi. So this becomes f prime pi equals to 8 times cosine 8 pi. And the cosine 8 pi is 1. You can put on the calculator. So it comes 8 times 1 is 8. So that's the slope. Now we have a slope 8. The point is pi comma 0. So we're going to write equation of line. So equation of line point slope formula y minus y1 equals m times x minus x1. So now we substitute m is 8, y1 is 0 and x1 is pi. So this equation becomes y minus 0 equals 8 times x minus pi. Now we distribute the right side, so make it 8 times x is 8x and 8 times pi is 8 pi. So y is equal to 8x minus 8 pi, and that is the equation of tangent line. So let's find the second derivative of f of x equals to 5 times 2 minus 7x to the power 4. So start with f of x equal to 5 times 2 minus 7x to the power 4. Differentiate with respect to x. So fx becomes f prime x. Write 5 and bring the power down. Multiply with the 5. 2 minus 7x. Now 4 reduces to 3. Multiply with d over dx of 2 over 2 minus sin x. So we are using the generalized power rule. Now multiply 5 and 4, 20. Rewrite 2 minus 7x to the power 3. The derivative to 0. The derivative of 7x is 7 times 1. Now we simplify this to minus 7 and write down 20 times 2 minus 7x to the power 3. We can multiply minus 7 in 20, negative 140, 2 minus 7x to the power 3. So the f prime x is negative 140 times 2 minus 7x to the power 3. Now we differentiate with respect to x again. So f prime x, make it f double prime x. Write negative 140, bring the power down 3, multiply by 140. And this becomes 2 minus 7x, 3 becomes 2. And multiply d over dx of 2 minus 7x. So to simplify, so negative 140 times 3 be negative 420. Write down 2 minus 7x squared, and the derivative of 2 is 0. The derivative of 7x is 7 times 1. Now 0 times 7 times 1 is negative 7. Bring down negative 420, 2 minus 7x to the power 2. Now multiply negative 7 times negative 420 becomes 2940. And just bring down 2 minus 7x squared. And that is the second derivative. Okay, so example 11. Find the second derivative of f of x equal 1 over 11x minus 6. So we're going to use the chain rule here. So let's write an f of x equal 1 over 11x minus 6. So let's use this rule. 1 over a is a to the minus 1. So we take 11x minus 6 to the top and let's make a power negative 1. Now we differentiate using the generalized power rule. So the power is negative 1, you bring it down, negative 1, and just copy 11x minus 6, and then subtract 1 from minus 1. And the end, you multiply the derivative of 11x minus 6. Now you just write minus 1, friends, 11x minus 6 to the power negative 2. Now the derivative of 11x is 11 times 1, the derivative of 6 is 0. So now simplify 11 times 1 minus 0 be 11. And just bring it down, negative 1, 11x minus 6 to the negative 2. Now minus 1 times 11 is negative 11 times 11x minus 6 to the negative 2. So this is our first derivative. Now we're going to, so now we differentiate again using the chain rule. So you write minus 11, bring the power down, negative 2, just write 11x minus 6 and subtract 1 from negative 2. And at the end, multiply by d over dx of 11x, this one, inner function, minus 6. So now you simplify negative 11 times negative 2 is positive 22, and 11x minus 6, and this becomes negative 3. Now the derivative of 11x is 11 times 1, and the derivative of 6 is 0. So this becomes 11. 11 times 22 becomes 242. And just bring down 11x minus 6 to the minus 3. Or you can rewrite second derivative as 242 divided by 11x minus 6 to the power 3.